Hi, today we're going to be talking about our Capstone project, which is the Hooli ride-safe close-pass synthetic sensor. For the project, Alex worked on the hardware, Jesse worked on the web app, and myself and Mark worked on the machine learning. The goal of our project is to decrease cyclist deaths and injuries and increase rider safety by enforcing 1 meter passing laws and warning riders of oncoming cars and possible collisions. In doing so, we hope to reduce emissions by promoting bike usage.
We 3D printed our case to make sure that we could securely mount all of our internal hardware, like our Raspberry Pi, our distance sensor, our Pi camera, as well as the internal rechargeable battery. On top, we have a green power button and a red record on off button, as well as a USB port so that the user may easily retrieve their data from the Raspberry Pi after their ride is done. We've mounted the GPS on the outside of the case so that it has clear communication with the GPS satellites. We mount the Hooli Ride Safe to the bike frame using two Velcro straps, one to go under the seat and one to attach to the frame itself. This was originally designed for a completely vertical bike frame, however, this one has a bit of an angled seat post. So, as you can see in a second here, we had to add some extra material to make sure that we could get a sturdy video for this test run. To start the recording, all one needs to do is press the red button. The red LED will turn on to show that you are in fact recording your ride. Our GPS sensor will ping our program many times and record your exact position throughout your entire ride. Our distance sensor will sense every time a close pass occurs.
On the Hooli web application, we can log into our account. It will dynamically load all of our previous activities. We can see here with the mapping, shows all of the route. We have our speeds over the ride video, as well as some statistics. We can add a new activity, fill in some of the metadata, pick a ride file, select a video, and it will send all of this information off to the backend to be saved and pushed to the database. Now we see the new ride pop up. We can see the route, all of the stats and the video that was chosen for the upload. Go back to the dashboard. We have routing with its own maps. There's heat maps, which show where the rider frequents, as well as selectable routes that center on the route. We also have aggregate statistics, so we can see basically how frequently people are riding. And then here we have all of the videos that are uploaded, so you can upload videos and search and sort. Lastly, we have route generation, so you can plot markers on the map, and it will route between these markers, and you can save this, and then you have a route to follow.
For the machine learning part of our project, we decided to wrap it in a Flask Python API. This makes it easier to call it and to utilize the machine learning functions when needed. The video and sensor data that's taken on the device gets uploaded to the website, and the website then calls the API to do the video processing and run the machine learning functions. The first step after getting a request from the web app to process the video is to do detection and tracking on the vehicles in the video. This is done by using an object detection algorithm to detect all the objects in the frames of the video. We ignore everything but cars, and then we take the cars and track them throughout the video. So we essentially create small video clips of each car that's passing through the frames. The detection and tracking is what you're seeing currently on the screen. As you can see, it's not always perfect, and it sometimes does mess up and double track the same car, but for the purposes of our application, this is perfectly fine. The small video clips that are created from each car are then used as the base to run the other machine learning functions, including license plate detection, speed detection, and collision detection. Unfortunately, some of our machine learning functions don't work as intended because of poor video quality, lack of image stabilization, and lack of training data. Finally, we wanted to thank you for watching our video and hope that we see you at our booth in the afternoon.